Good afternoon to all the panelists and all the attendees. Thank you very much. It's a pleasure for Emilia Romagna region to organize this webinar with the CMCC and also with the ARPAE Emilia Romagna. This is a webinar of the dissemination action of Clara project, where is involved also Emilia Romagna region. And it's a very important project for the definition of climate services that are the very tools for our future in the fight of climate change. Now I am Patrizia Bianconi. Maybe many of you knows me for the other webinar and other action in Emilia Romagna region in the fight of climate change. And now I give the floor to Stefano Bagli from CMCC to give us some technical information, some more information about the webinar of today. Thank you, Stefano.
Thank you, Patrizia. My name is Stefano Bagli. I'm here on the behalf of CMCC. I'm not working for CMCC. I'm working for Gecosistema, my company, that is part in the Horizon 2020 Clara project. I'll give you just some technical details about this webinar. The moderator will be Vittorio Marletto, and he will be in charge to present all the panelists and also to manage the question and answer session. The webinar is actually recorded, so you can you will receive the recorded webinar through a dedicated email. You can have another view of the webinar from home, and there is a possibility to pose some question to the panelists. You have in the bottom bar, you have the button question and answer. So I strongly encourage you to pose dedicated question. And after the end of each presentation, there will be time to answer to the question that are reported in the chat, in the question and answer dedicated button. So that's all. This is the second webinar of this Horizon 2020 Clara webinar series, organized in collaboration with the Climate Europe and also with the Clarity Project. So that's all. I'll give you the floor to Vittorio Marletto to start the webinar and to start the presentation of the panelists. Thanks a lot.
Thank you, Stefano. Hello, everybody. This is Vittorio Marletto from ARPAE. I'm in charge to manage the Climate Observatory of ARPAE that was created last year. So it is a quite new initiative from the Regional Agency of Environment for the region Emilia-Romagna. Now we are talking about climate services, and we will have some distinguished guests that can present their experience in their field. The first one of the speakers will be Patrizia Bianconi from Regione Emilia-Romagna, that already introduced this webinar, and after her, we will have a presentation from Sandro Nanni. Sandro Nanni is a physicist like me. He is in charge of the activities of weather forecasting for civil protection at ARPAE. And then a very young colleague of mine, Alessandro Pirola, who is in charge of remote sensing activities. And the final presentation will be from engineer Chiara Benaglia, who works in the Land Reclamation Board of Romagna. In Italian, we say Consorzio di Bonifica Romagna, and she will talk about coastal application of climate services. Now, just a few words about climate services. This is a new phrase, a new expression. It is so new that you cannot even find it on Wikipedia. So this is a problem that we have. We are all dealing with this activity, and we cannot find it on the most common and most consulted encyclopedia on the web. So it is really something a bit esoteric, but very important, because what we define as climate services are all sorts of activities that have to do with information, data, and projections on climate change. All these data, information, and projections have a practical use. And so weather services now are being also accompanied by climate service sections who are doing all sorts of interesting things. For instance, in the Clara project that was already mentioned, that organized jointly with other projects this webinar, we developed in the last 3 years something like 14 different climate services in very different subject matters. For instance, irrigation, for instance, renewable energy, and other examples are air quality and several other sectors where the climate services are being developed by a large number of partners from all over Europe. So let's have an idea of what climate services have as importance for a region like Emilia Romagna. Emilia Romagna is a region in northern Italy with about 4.5 million inhabitants. We have a very large agricultural area, but it is also a rather industrial and commercial region. So there are a number of situations like the mountains, the plain, the coast, and the cities. All these situations have to deal with climate change, which is very evident here, and we are documenting climate change in our region every day, almost. And so we have a role for climate services that will be explained in more detail by Patrizia Bianconi from Regione Emilia Romagna. So I leave the floor to her, and I am also thanking her for being the organizer, co-organizer of this event. Thank you. Patrizia, the floor is yours.
Yes, thank you so much, Vittorio. I want to start with share my presentation. Few seconds. I don't know if you can confirm you see my presentation.
Yes, we do.
Yes, it is
okay.
perfectly.
Thank you so much. So in a very few minutes, I wanted to explain, to show what is our recent climate services, in particular for the activities for our regional municipality and union of municipality for the development of their sustainable energy and climate action plan. As you know, Emilia-Romagna region approved in December 2018 with an assembly resolution, a very important document. The name of this document is the Climate Change Mitigation and Adaptation Strategies for the Emilia-Romagna region. And this is a very important document because we have many objectives to develop this kind of strategy. In specific, we have as a goal to provide an overall framework to all regional sectors, because we start with a mapping of a lot of mitigation and adaptation action and measure that are already implemented in Emilia-Romagna region or that are wrote in the plan and program already approved in Emilia-Romagna region. But after this, we make a gap analysis to define what are the measures and the action that could be necessarily implemented in the future, in the next program and plan or law, and also in the review and update of regional plans and programs. Another main object of the climate and mitigation, adaptation and mitigation strategy of our region is where a mainstreaming process to involve all of the regional employees or try to involve all regional employees in the definition of this document, with the aim to increase the awareness on the climate change issues inside all kind of decision, all kind of action of our region. Last but not least, one of the other goal and also a main output of this strategy is a process of involvement of local stakeholders in order to integrate adaptation and mitigation also in sectorial policies at local level in sense of municipality and province. One of the main outcomes, as I already said, is the Regional Forum for Climate Change, is a permanent forum that we launched in May of 2019. And the target of this forum are enterprises, regional local authorities, and obviously also stakeholder and citizen in general. The objectives of this forum are, again, awareness, raising information of meaning of adaptation and mitigation, to create, as I already said, a culture of risk and also the vulnerability, the concept of vulnerability for the risk of climate change effect. But also the other objective is the dissemination of knowledge and training on solution and practice. And one of the most important goals is also to develop tools and methods for local authorities, also for their plans. In general, not only for the SECAP plans, Sustainable Energy Climate Action Plan, but in general for all kinds of plans that our municipality are called to define, also in this very important period. So in our regional strategies, we start with obviously a climate variability observed, provided by ARPAE Emilia Romagna, regarding the temperature, minimum and maximum, respect the past years, in particular respect 1971 and 2000, and also the same, the rainfalls, the annual precipitation respect 1971 and 2000 in Emilia Romagna region. So we can summarize this climate variability observed in Emilia Romagna with these two sentences. We observed that there were significant increase of minimum and maximum temperature, both at annual and seasonal. And in particular, at the seasonal level, the greater recorded increase is during the summer. Regarding the rainfall, average cumulative annual and seasonal rainfall is slightly decreasing, except in autumn, where a positive trend is maintained. So this is a very synthesis of the climate variability observed in our region. At the same time, for defining strategies, we need to know what could be the future of climate variability in Emilia Romagna. Again, ARPAE Emilia Romagna provided us a forecast, some projection for climate variability for 2021 to 2050, also for temperature, minimum and maximum, and also for the precipitation. Again, we can summarize the future of our climate variability in this point. For the next period, 21st to 2050, the minimum and maximum temperature can be increased about 1.5 Celsius degree in winter.
Patrizia, sorry, we cannot hear you. Patrizia?
Vittorio, I think we have lost Patrizia. Now she left the the meeting, maybe just wait 1 minute. Let's see if she can rejoin us again.
Ah, okay. So she has the problem. I thought I had one myself. No.
No. I think it's for all the webinars. Let's wait another minute. Yes. Okay.
Sorry,
Patrizia,
I don't know what happened. It's the first time, but any time there is a first. Can you hear me now?
Yes, go ahead. Yes, please.
Oh yes, okay, sorry.
Thank you.
I need also to share the video, or you can see me or the video.
We see you, and not you have to share your screen.
Yes, sorry again. Okay, sorry. Okay, I can continue. Okay, go on. Okay, about these climate services, as already said, our goal was to give a tool and to support, in particular, municipalities and union of municipality to compose their sustainability, energy and climate action plan, having a basis of climate scenario at a regional level defined with a single methodology. So we define homogeneous area and indicators in the first step. In the step 2, a build and data sheet for each homogeneous area. And in the step 3, we show this product and this tool to the municipality and made available on the Emilia Romagna website. So starting from the division that we already done in our strategy of the land of the territory of Emilia Romagna in ridge, hill, lowland, coastal and urban areas with a different definition. Ridges include municipality exceed altitude of 800 meters above the sea level, hill between 280 meters, lowland and lower than 200 meters, coastal include the municipality facing the sea or than 5 kilometers away, and urban area include the municipality with more 30,000 inhabitants. We divided again our land, our region, in also in a west and east homogeneous area. Also because we found with ARPAE Emilia Romagna that there is an important difference in terms of climate projection among the west and the east of our territory. In the same way, we have a north coast and the south coast. So at the end, we will have 8 homogeneous areas and 10 urban areas, are the 9 capital of province, plus Cesena, because it's very important, in any case, a town, important town. Also, we have as our objective, our project was goal was targeted for the municipality, but in particular for the municipality who made a project application in terms of SECAP to the recent call financed by Emilia Romagna region. So we define also the indicators. A very minimum basket of indicators are 7 climate vulnerability indicators as indicated in European Covenant of Measures SECAP guideline. These indicators are average annual temperature, maximum summer temperature, minimum winter temperature, tropical summer night, summer heat wave duration, annual precipitation, and dry summer days. So after this, ARPAE Emilia Romagna Observatory, as Vittorio Marletto said, provided us the statistical regionalization at the global climate models. So they used 6 different climate models, a model average of these 6 different models, with using a climate data set of Heraclito, and for a spatial resolution of 5 per 5 kilometers, they provided us the specific data sheet and projection for each homogeneous area. You can see here as an example, for example, for Eastern Hill, we provided for each homogeneous area this figure where you can see all kind of information, and in particular the climate reference value starting 1961 and 1919, and the future climate value. This is very important for the plan, for the SECAP plan. This is for each homogeneous area and all for 7 indicators that we defined at the start, at the beginning of the project. So we provided also a correspondence for each province of our region. You can see Reggio Emilia province, for example, a table with each municipality included in the province, and for each municipality the specification of the homogeneous area that they are involved. In some cases, each municipality is interested not only in one homogeneous area, but also in 2 or 3. The first column, in the first column is indicated the area prevalent in the homogeneous area. So at the end, we made a booklet of this data sheet for each homogeneous area, so 18 for the different area and 10 for the urban areas, and they are available in the Emilia Romagna website in the climate change page. You can see also the web address, and this is a very important instrument for all the municipality, not only obviously for the municipality who presented the project, the proposal to the call of the Emilia Romagna, but all the municipalities that in Emilia Romagna want to pass and to compose the adaptation plan. Thanks for your attention, and sorry for the incident in my connection. Thank you.
Thank you very much, Patrizia, for your presentation. You showed us how we have to provide climate services in terms of climate projections to municipalities and to the regional territory, in order for them to start adaptation plans at the municipality level. I don't see questions and answers from any in the audience. So you always have the possibility to add your questions. There is a small command in the low part of your screen, a written question and answer, Q&A. And there you can put your observation or questions to the speakers. So it's now time for Sandro Nanni to connect and to share his slides on the subject of heat waves and adaptation to heat waves in Emilia Romagna. Sandro, can you hear me? You should switch your microphone on. Your microphone is okay, and you should also turn your video on so that we can see you. Okay, Sandro, hello, and you can start. You can start your presentation now.
Okay, is it right, the presentation in this frame?
Sorry, you should start the presentation because we are seeing only the slide, but you should push on the command of presentazione on top. Okay, that one. Okay, thank you.
Okay, good morning. My presentation is also the work of 2 colleagues, Stefano Sayani, that is the expert in our region from the health, in ARPAE, sorry, and my colleague Giovanna Pierretti. Sorry, the next one. Okay, so we start with we are in the frame of the climate change. All of us know that you have to see the impacts, the adaptation and vulnerability. We start with the, as Patrizia said before, the increase of the temperature that is a global problem for all the world, but also in our region we experimented just the increase of the temperature. So this is various scenarios for the end of the century. In the southern Europe, if we see the scenario 4.5, that means that the concentration of NO2 will be more or less 538 ppm at the end of the century. We see that the increase of temperature will be about 2 degrees with this in confidence level. And then one of the effects will be the increase of the heat waves. Very probable. So this is in the future we can expect that also the day and night hotter, but also the specific heat waves. Now we can see the effects on health, directs and indirects. So there is a strong evidence that the heat waves will be present in the frame of the climate change. So with respect to other extreme events that occurred, flooding, extreme rainfall, drought, hurricane and tornado, the heat waves are the more evident that will be occurred and will be occurred in the future. So there is a sketch of the response of the human body to the sun, and also the environmental factors, so the air temperature, but also we have to take into account the air humidity and the wind speed, that is a reduced factor for the temperature that the people can see and say. So there are a lot of discomfortable bioclimatic indices. We use the TOM indices. This is the formula, is a combination of temperature of the air and the dew point temperature. The dew point temperature is the temperature to which air must be cooled to become saturated with water vapor. So this is really a combination of humidity and temperature. So this is the box where we can see increasing the temperature on the left, and also increasing the humidity, relative humidity on the right. You have this area very dangerous. Now we can see some other indication that the hot temperature risk is not homogeneous, but depends from the population. So a lot of factors can influence that: the age, the race, economic condition, but also if you have some diseases, diabetes, cardiovascular, also previous break attack. There is also behavioral factors, so like loneliness, live in home without conditioner or live in urban areas. And we will see that there is a lot of difference to live in urban areas with respect to the outside. And also weakness situation of the people. So all that factor are be considered in the sense, in the meaning that the heat waves are different, the effect for the population. So we can see that the rate of death with respect to the age, so we can see the clear and steep increase with the age and the risk of mortality. And also another problem is not only the summer season, but also what occurred in the previous season, mainly during the previous winter. So if you arrive in summer with a low winter mortality, you will have more possibility that in the summer the number of deaths will increase. So it's quite common, it's not a surprise, but the graph shows that there is a lot of difference in the situation presenting in summer with respect to the condition of the previous winter season. Extreme temperature heat waves. So we can see here, in this case, we plotted the maximum apparent temperature. As I shown before, there is a lot of indices to compute the discomfort. And so in this case is a graph with the maximum apparent temperature and the mortality. And you can see the steep increase with the respect to the condition of increase of the maximum temperature, and the effect also that there is not immediately an increase, but there is an effect of increase of 2 or 3 days after the beginning, that you will find, we will find the increase of the number of deaths. There is also an effect if the heat waves will arrive early in the season, in the month of June. In the Emilia Romagna region, we experimented also 1 year where the heat waves occurred in May, and this the most dangerous with respect to the situation of July and August. This is a graph that there is shown the situation in a lot of cities in Europe, and you can see the difference where in brown there is for each city all the heat waves, and in orange and in light green the difference with the persistent or long heat waves, and the third one, the green, long and strong heat waves. Between orange and green, there is no difference. The step, the jump is between all the heat waves and the heat waves of long duration. And this is it's not the same for all the city. If we see this situation in Italy, Rome and Milan, the difference is very clearly. In some other situation, as Valencia in Spain, the difference is very low. This is the computation, the evaluation of the TOM index in the city, Bologna city, from the 2001 to 2019. It's very, very evident the case of 2003. It was we can see that the interest of the heat waves started after this year, when very, very many thousands of people died in this year. And the fact was that the situation occurred not only in southern countries, Spain or Italy or Greece, but it was very, very strong effect in a country like France. So they experimented for the first time the situation of the heat waves. It was a surprise for the country. So this is the evaluation of the seasonal mean value of the TOM index, and we can see a large variability year for year. And this is the evaluation starting from 2006, when we began to compute the TOM index and to produce our service. So we can say that it was a climate service provided before the definition of climate service. We started with in 2006, and we have a free value of the TOM index. This is the TOM index is in temperature, so the centigrade degrees. 24 is a weak discomfort, 25 is a mean discomfort, and 26 is a strong discomfort. And you can see the situation here by here. So we can note that in some years from 2000, sorry, tornare indietro, I don't know.
Puoi usare la freccia e tornare indietro, la freccina in alto.
Qual è la freccina in alto?
Freccina sulla tastiera, Torna indietro di una slide.
Aspetta. No, qui sono andato
indietro. Mi dispiace.
Aspetta, allora andiamo qua. Sorry for... ecco qua. The red bar are in some years are not present, but in 2015 or the last year 2019 it was more, in this case 10 days, in this case 6 days. So are strong situation. And we broadcast this information in our website. We divided the region in the 9 provinces, as Patrizia shown before, and also we distinguish the flat area, the hilly area, the mountain area, and the urban area, because as you know, the city are a problem of heat during the night, and so it's the value of the TOM index is easier that are greater in the city. So this is a forecast for today. We make this forecast every day, 7 days to 7, from the more or less the 15th of May to 15th of September. And this is the graph of the TOM index in Bologna city starting from 15th of May until yesterday. So yesterday we lived a situation of orange, so the discomfort mean discomfort. And so we make the forecast for every day for 3 days, today, tomorrow, and the day after tomorrow. These forecasts are public on our website, but we have also a very, very large list of hospital and doctor, medician on the territory, and we send an email to all the people, are very some thousand of people in the region, because also the people, the doctor, the medician in the territory knows the people that they follow, and so knowing that the particular disease of the population, they can put the attention very, very focused to some specific situation. So
Sandro, Sandro, you have 2 minutes.
Okay. So I can switch. This is the mortality and the Tom index. So with until 25 degrees, there is no particularly signal of mortality, and after there is an increase very, very clear. So this is also the same with the value 24, 25, and 26 degrees. Weak, medium, and strong. This is the same. The impacts, this is the increase of the during the summer. It is in particular this one increase of the death, and this the last is the situation of the urban areas, the isola di calore, the high hot situation due to the evaporation, and then this the sketch that show the effect of the different roof can have to the temperature of the city. This is the last, I think, the different during the night. In this case, the hour of the night. Viale Silvani 2 is in the city of Bologna, and this is on the country, and we see the difference also of 5-6 degrees. The difference is lesser during the day with the maximum temperature, but during the night it's very, very sensitive. Thanks for your attention.
Thank you very much, Sandro. Thank you. I am sorry, but you used all the time, and so we will keep maybe the one question there is for later on. And I would like to switch to a rather different subject, and so leave the floor to Alessandro Pirola. Sandro, you can turn your microphone and your video off, please. And now it's turn for Alessandro Pirola to share his slides on the screen.
Can you see me?
Yes, we can see your slides. Thank you very much.
Hello, everyone. This is Alessandro Pirola, and I work for ARPAE with Vittorio, Marletto, and especially we work together in Struttura Idrometeo Clima. And today I'm going to speak about early crop map for irrigation climate services. Maybe this I can put somewhere. Okay, this is better. No. Okay, and a few words about ARPAE. Well, ARPAE is the regional agency for prevention, environment and energy of Emilia Romagna. And its key goals are controlling the state of the environment and supporting the sustainability of human activities. Basically, on this background, I work with remote sensing data. So in ARPAE, we have many applications and projects that include remote sensing, and some of them are I-called climate service that I'm going to speak about it later. Snow cover mapping and snow water equivalent over the region, especially during the winter months. Vegetation stress anomalies monitoring during the summer period. And the positive project. The positive project is regarding the use of satellite imagery for precision irrigation and fertirrigation. On the left, you can see an example of the vegetation stress anomalies. And on the center, you can see on purple the snow cover mapping all over the north of Italy. This is an example of I called last year map. We realized, and sorry because the legend is in Italian, but anyway, you can know that each color is a class of a different crop. And as you can see there by the black border, we are not analyzing the whole region Emilia Romagna, but just the plain area. And I'll explain you later why. A few words about how is born I-called and what is talking about. Basically, I-called climate service as different steps. The first one is the early crop map, and is a procedure that allows the special individuation and quantification of the crops present in Emilia Romagna region. And this is the first step that is needed for the second one. The second one use early crop map as input for the criteria water balance model. In this way, it permits to the seasonal prediction of expected irrigation water for the coming summer. It is really important statistics because in this way we can release a bulletin every year that have numerous information for local water management authorities. And in this way, they can better handling the water resource. The early crop map is agricultural herbaceous crop classification. And to make it, we analyze a series of multispectral satellite images. The area of interest, as I said, is not the whole region, but it's just the plain area. In fact, this area is mainly dedicated to agricultural production. I mean, mainly for the surface percentage. You can think that more than 70% of the area is dedicated to agricultural production. And the whole area, the area of interest of I-called is more than 11,000 square kilometers. And the classification scheme. Basically, what we aim to do with the classification is divide the herbaceous crops into 3 macro classes with different water needs. And to do that, we analyze just three images derived by satellite. And these images are taken in some periods of the year. Especially, they are called window. And the first one is autumn, the second winter, and the third spring. And these are selected to maximize the phenological difference between the crops. In this way, we can find summer crops, winter crops, and perennial crops. Before the classification, there are some operations that are basic operations, but needed to do to the data. On the right, you can see a couple of examples of Sentinel-2 Copernicus data images, one in real color and the second one in false color. We use a variety of sources to get the data like Landsat 8, Copernicus Sentinel-2 or DMC-2 constellation. The reason because we don't use just free data as Landsat and Sentinel is because in winter period and in spring period, it's not so easy to get clear images without clouds. And as you can suppose. For this reason, we try to get different sources to have the result like this one. For example, the last year we was lucky and we could get just the Sentinel-2 images. Another important thing to say is that the agricultural panorama is a highly fragmented, has a highly fragmented land cover. For this reason, we often use more than just Sentinel or Landsat. We use some of them, but the spatial resolution that we use is always 22 meters. We know that with this spatial resolution, we can have good results, and so sometimes we need to resample the data. And we also create, as a second step, an agricultural mask. This is really important because in this way we can analyze just only agricultural pixels. And in this way, we minimize misclassification, and we can just see if the pixel and the land is vegetated or not vegetated. And now we go to the classification algorithm. The data are we use of different of this multispectral images, the red band and the near infrared band. With these two bands, we create a normalized difference vegetation index, NDVI, really famous index that can quite easily find out if on the ground there is vegetation or there is not. Actually, you can see if there is not vegetated land, lightly vegetated, or highly vegetated. In this way, we can apply specific threshold and for each window, and we can see if which one of the three class, summer, winter, or perennial crops there is. As you can see on the right, on the table on the right, mainly the summer crops are characterized but not vegetated land. We can find some vegetation, but it's just a spontaneous vegetation, and a specific characteristic of this class is that is not vegetated on the spring. While the other two are vegetated on the last window, while are not vegetated for the winter crops in the first part of the year, and while the perennial crops are vegetated more or less all over the winter period. And here I put some examples. The images that you see are false colors, so I mean that you can see green, red, and near infrared band. So if you see blue on the window, the W1, 2, or 3 means that is bare soil, while if you see orange or red means that is lightly or highly vegetated land. And as you can see on the left, there is an example about the summer crops. And you can see how there is the land pointed by the arrows is not vegetated in the three windows, and then it's classified correctly as summer crops. While on the right, you can see how the land that is in the first window not vegetated became more vegetated in the second and highly vegetated in the third, and then it's classified as winter crops. Of course, there are also other classes like vineyards and orchards that is not so easy to classify by remote sensing. In fact, they are mainly vegetated all over the year, similar to perennial crops, and so it's not possible to classify them by remote sensing. And so we use a regional archive to pass on the classification these areas. And at the last operation that we do before the vectorialization of the data, as you can see on the right, the final result that is used by Criteria software. And we select 1 hectare as the minimum size of the polygons. In this way, we try to minimize misclassification and errors and to have a good size of the fields. The last part of the work is quality assessment. I didn't say before that all the process of classification is completely automatic. That means that we don't need any truth ground. So that is really important if you do a periodical service because if you don't need any ground truth, you don't need to go on the field, and you can spare money and time. But we do a field survey actually on every time period of the study. That because we need to know if the classification that we are carrying on is precise and how precise it is, because from this depends the forecast of criteria software. For this reason, as you can see in the first picture on the right, the red dots are the fields that actually we monitor every year. And you can see, so we check on field what is going on. And at the end of the year, after the classification, we made a confusion matrix. So we compare what actually there is and what the software has made in the classification. And so we can know how precise it is. Mainly, we have a precision that is around 98, 99%. Some year we can go around 95, depends by the year. And also an important fact to know is that the climate is changing, so also how fast is growing the vegetation is different. So it's not possible to have really relying results without knowing what's really going on. So also sometimes go and see on the ground, on the field is really important. Thank you for your attention, and if you have any question, I'm here.
Okay, thank you very much, Alessandro. You were very fast, and so you left some more time to the following presenter, who is engineer Chiara Benaglia. She's a startup. Hello.
Hello.
You can start and share your and you have 15, maximum 20 minutes to explain us what we are talking about, which is especially related to the coastal city of Cesenatico in Emilia Romagna. Thank you very much.
Is everything okay, Vittorio? Do you see my screen?
Yes, we see the screen.
Okay. Hello, good afternoon to everybody. My name is Chiara Benaglia, and I work at the Hydraulic Land Reclamation Board in Romagna. I really thank everybody for being here. And in my speech, I will explain how we use weather forecasting models to manage flood risk in our district. Okay, we will focus on Cesenatico, that is a small and wonderful city overlooking the Adriatic Sea, and which is famous for the beauty of its Porto Canale, an historical channel which crosses the center of the old town. In 1996, Cesenatico was hit by a terrible flood. At the time, the Central Canal was the only exit to the sea of all the inland waters for a basin of about 130 square kilometers. And the causes of the flooding were three. Firstly, the subsidence, which had significantly lowered the ground with respect to the sea. Then the climatic changes. In 1996, a rain occurred, which lasted almost 48 hours. With 200 millimeters of total precipitation, with a return time of 100 years. At the same time, we had a storm, and this caught everyone unprepared. Finally, anthropization and soil consumption, which in 1996 in Romagna showed maybe for the first time the real effects. The subsidence in Romagna region has caused a drop of the soil of about 1 meter from 1950 to today. And the subsidence effect is evident also if we analyze the increase in the drainage systems with pump stations of the Romagna Reclamation Consortium over time. For example, in 1975, we had 11 pump stations in Romagna, mainly in the Ravenna area. Then in 1996, as a result of the subsidence, the pump stations became 21 due to the lowering of the soil and the impossibility of the gravity drainage. And the last year we analyzed, in 2015, the pump systems rose to 47. So this is the Adriatic Sea. These are pump stations. So you can see how the increase was rapid. And this is the tangible sign of the lowering of the soil in our region. The Porto Canale, the canal in the old town of Cesenatico in 1996, at the top of the piers was at 1.1 meters above the sea level. And it was frequently affected by flooding from the sea, or in any case by storm surges, which due to the effect of the backflow, limited the upstream outflow. When we started our hydraulic studies about Cesenatico, the forecast of the maximum level of the high tide and storm was 1.80 meter above the sea level for a return time of 10 years and 2.2 meters above the sea level for a return time of 100 years. So guaranteed flooding in this condition. This is what happened in 1996. In these photos, the overflow of the Porto Canale is clearly visible. The town hall also flooded, and not only that time. And all the houses in the center were subject to frequent flooding, and citizens were used to protect themselves with barriers. After 1996, many hydraulic studies were started by our Reclamation Consortium and also Emilia Romagna region for the resolution of Cesenatico problem. An anti-flooding alternative could have been to bring piers of the canal to 3.0 meter or about the sea, over the sea level, with a relative rise of 2 meters from the current ones, but it would have been obviously very impactful from an architectural point of view. So among the many solutions we analyzed, it was decided to create a new diverter channel which intercepted the inland flows upstream of the city and brought them to the sea at a new point of entry. So in this great animation, we see the Porto Canale and then the new diversion channel that we decided to build in this part of the territory, far from the old town of Cesenatico, whose position here. The remaining, the flow in entrance to the Porto Canale, as the basin is 130 square kilometers, is evaluated in 180 cubic meter per second, time of return 200 years. With this new diversive channel, we are able to flow 110 cubic meter per second, and the part who remains will be filled into a system of extension basins. Okay. I lost my mouse. So this is a scheme. Complete the slide and explain. This is Porto Canale in the old time. The idea was to close Porto Canale on the seaside to protect the town from the storms, and then to create another gate at the beginning of Porto Canale to protect from the floods of the internal waterways, building a new diversion channel using pre-existing channels to connect them. The new diversion channel had to cross the railway and two roads. Initially, we thought of elevated bridges, but since the agreement with the Italian road manager, ANAS, was not reached, a siphon was chosen. The first work carried out was the Porta Vinciani Gate in 2006. They take up the ancient idea of Leonardo da Vinci and close the port through two motorized lanes. Behind the doors, we have a pump system in this position of 18 cubic meter per second that raises the waters of the historic center, the old town. The first photo shows the gate open, these are Porta Vinciani doors, and the second, the gate while closing. The third shows the pumps in operation, hidden under the dock of the port. The second work was the diversion channel. The most difficult part was to design and build the siphon that would cross the railway and two high traffic roads. In this aerial photo, you can see the construction. You will see the railway, the road number 1, road number 2. This is the channel upstream, the siphon, and in this position, the diversive channel downstream. The bypass siphon we saw in the previous slide is regulated by 4 stainless steel sluice gates, 2 at the entrance and 2 at the exit to optimize the functioning. This is the bypass complete and seen from upstream. Then the diversion canal, called the Tagliata Canal, was built, reaching the sea out of the historic town. This is the same channel, and the view is from downstream, from the sea. At the same time, the creation of expansion tanks, basins also began. This is the first, built in 2009. This is finished. We have in construction another basin of 23 hectares. And finally, a closing gate was built upstream of the Porto Canale at the beginning. The sluice gate, this last one, was designed to disappear so as not to spoil the view of the historic canal in the town. And also the control room with electrical panels, hydraulic power unit, and the electronic unit was built inside the concrete structure. Now it can be accessed with an elevator or an emergency staircase in order not to waste the marvelous view of the old town. This is the sluice gates at the beginning of the Porto Canale when we finished them just before the test. It was the year 2012. So the sluice, the diversion channel system was completed in 2013. Plans are still underway for further expansion basins in the hinterland, but in the meantime, an integrated management of the hydraulic system has started since 2013 in order to protect Cesenatico. The management of this complex hydraulic system is very, very delicate. This is the Porta Canale, the old town. This is the new diversion channel, Porta Vinciani Gate, Ponte Brigato Gate. The Porta Vinciani gates on the canal port must be closed well in advance of the storm. So accurate forecasting models are required. The closure of the Porta Vinciani gates prevents fishing boats who are here on the canal from going out to the sea even for 2 or 3 consecutive days. So socioeconomic phenomena have to be evaluated carefully. The closure of the Porta Vinciani gates in summer, rare but not impossible event with deviation in this position, can lead to temporary bathing prohibitions, as the mouth of the diversion channel is very, very close to the beach. And so the decision must be taken very, very carefully. If the storm coming from the sea is concomitant with intense precipitation, the closure of the gate, of the Porta Vinciani gates, can still cause flooding because the expansion boxes, the basins in the hinterland are not completed now. so decisions are really often very difficult to take. And this is the system. We start with an alert, weather alerts, forecasts, weather models. Then the mayors decides, after consulting our land reclamation consortium, to close the Porte Bianconi doors, gates, next to the sea, in advance of the storm. So models are very, very important in this case. Then there is the closure of the gate Ponte del Gatto at the beginning of the Porto Canale, and this is by our land reclamation consortium. Then phase number three, pump stations of municipality, the pump station of the municipality of Cesenatico starts working, because if it's raining, this part of the town has to discharge flows in this pump station. We open the bypass gate, and so water can flood toward the sea in this position. So the first consultation for our reclamation consortium and the municipality of Cesenatico begins with the receipt of the yellow weather alert from ARPAE service in Emilia Romagna, from Dr. Sandro Nanni, who talked before. And we analyze the wind intensity forecasts for the next 24 hours using the model of ARPAE Emilia Romagna, who's on the website. So the working group, which is composed of the technicians of the reclamation consortium and the technician of the municipality of Cesenatico, analyze the wind intensity forecast for the next 24 hours using dynamic forecasting models. The pre-alarm condition for the closure of the Bianconi gates at sea is wind expected to exceed 35-40 kilometers per hour. And further pre-alarm condition for the closure of the Porte Bianconi gate is the direction of the wind. These are the dangerous winds for us, so direction is very, very important. Wind direction is dangerous when coming from north, from in Italia, northeast, east, and southeast, Scirocco. This is the most dangerous. This is the buffer scale. I think that everybody knows it. And the storm forecast is also analyzed using a dynamic model of significant high of the offshore wave, which begins to be problematic for Cesenatico, dangerous in very rough sea conditions. So when the yellow scale is reached, waves high more than 2 meters. The prediction of the direction of the currents and the wave heights is carried out also by analyzing another model. We use the model of Consorzio Lamma, Tuscany, Italia, as a comparison with the previous one. We see in this model the direction and the intensity of the waves. And finally, the forecast of the rain is analyzed, especially to decide whether to completely close the sluice gate at the entrance of the Porto Canale, or whether to partially close it. Usually, if the expected precipitation rainfall is less than 50 millimeters per day, the upstream sluice gate Ponte del Gatto closes totally, and so all the flood goes to the diversion channel. But if the expected precipitation is less than 50 millimeters per day, the upstream sluice gate Ponte del Gatto closes partially, so in this position normally, allowing a part of the hydraulic flow from the hinterland to enter the Porto Canale towards the water pumping plant located behind the Patrizia. We have seen it before. Once the closure decision is made, the system is controlled, is monitored 24 hours a day. We monitor rain levels, drainage plans, mainly using the remote control of the Reclamation consortium, who is called the WINET7. We monitor rain and levels, and the municipality of Cesenatico monitors the sea level with the level sensor in the sea. This is an example of our remote control. This is Ponte del Gatto gate. This is bypass gate at the entrance of the diversion channel. And I conclude with the data analysis from January 2018 to July 2020. The system of deviation of the outflows has been activated about 45 times, with an average of 18 events per year. So a great success, we believe, because for 18 times a year, Cesenatico has been saved thanks to this system. The height of the sea below the coast that led to the closure of the gates and the deviation of the outflows in the diversion canal varied from 0.6 to 1.20 in this period that I analyzed, really short period. But for example, in 2015, we had a sea level of 1.50. That is the new historical maximum of sea level in our region. And so, thanks for your attention and greetings from Cesenatico. Come and visit this wonderful city on the Adriatic Sea, where science meets beauty. This is the Ponte del Gatto gate. As you can see, it's integrated by an architectural point of view with the wonderful and old Porto Canale. Thank you.
Thank you very much, Chiara.
Allora, I'm not able to stop sharing my video, so I ask Stefano Bagli to do it for me, because I tried before, but okay. Thank you.
Okay. Thank you very much for your very complete presentation. I am curious to know if you already have done some, say, studies or discussions about the future of your system in the coming climate.
Well, the general study of Cesenatico has a provision of 135 hectares of expansion basins. So the future for us is this: no longer gates, no longer pump stations, but river basins, expansion basins in the inland. The study is about, the general study was made in 2007 with a return time of design of 200 years. And so it's a very general and ambitious study. We will go on by creating, thanks to the help of the Emilia Romagna region, other expansion basins. This is our purpose. As I said before, the next one will be built in 2021, next year, in Cesenatico, and it will be 23 hectares with a volume of 500,000 cubic meters.
So 500,000?
Yes, 500,000 cubic meters of volume, water volume that we can store.
Okay, thank you very much. It was very interesting.
Thank you to you.
There are some questions. One question is for Sandro Nanni. I don't know if Sandro Nanni is still with us or he went away. Are you still there, Sandro?
Yes, I'm here.
Okay. So there is a question for you. Margareta Braille from CMCC asks you, why do you include race among the individual factors in your presentation? We were talking about heat waves and the effect of heat waves on population. So I guess this word race was included in one of your slides, and so it raised the curiosity of Margareta.
Really, I found this
definition, yeah.
Evaluation in the slide of my colleague is a mediation, so I think it's a factor of study made in the year. So it's not my choice, is an indication that different population have a different response to the heat waves.
So if you place say a Northern European white male in the middle of say African climate and heat waves, the response can be very different compared with say local women, just to say something to make a difference.
The problem is the difference of the skin of the people.
Yeah. So I guess this is a reply from Margareta. And then there is another question. Thank you. Thank you, Margareta, for asking. There is a question from Roger Street. He's asking, I guess, to Chiara Benaglia, if there is increased confidence in using the system of the gates, and what is the impact on the frequency of the system? I mean, is this leading to an increased use of this system because you are more confident on it?
Yes, during these 7 years, we really surely increased confidence in using this system. We are very prudential when we use it because, as you have seen in the presentation, the effects of floods in the old town can be very, very hard and dangerous. But we have improved our confidence. I really can say it. And yes, we noticed that the frequency is increasing. The number of activation of the system of the diversion channel in the year has increased. I hadn't enough time to study this increase, but I want to do it. From my experience, I can say yes. Climate changes are visible also in this increase of this activation.
Okay, thank you very much, Chiara, and also to the floor of attendees. And so I thank again all the presenters that presented the very varied applications of climate change in very different situations, in the countryside, on the seaside, on urban areas, and so on. And so I leave the floor for the final information and for the closure to Stefano Bagli. Thank you, Stefano, also for keeping us working from the director booth.
Thank you, Vittorio. Thank you, everybody. Thank you to all the panelists for their excellent presentation. Before closing, I would like just to remind that the webinar has been recorded. So together with the PowerPoint of the presentation will be made available and published on the web. So follow us. You will also receive a specific email. And before closing, I would like to invite you to the next Thursday, the next Climate Thursday. There is another event, another webinar, again organized by Clara, Clarity and Climate Europe. At July 3rd 9:30, there is at 11 o'clock another webinar dedicated and focused on urban flood risk. So we will present a very interesting climate service dedicated to urban flooding. So I would like to say again, thank you to all the attendees, all the panelists, and also to Vittorio as moderator. And I strongly invite you to register for the next webinar next Thursday. Have a good evening. Bye.
Bye-bye, everybody.
Bye-bye.
Thank you again.
Bye-bye.